The standard academic critique of artificial intelligence rests on a specific claim that algorithms cannot truly understand because they lack human context, physical embodiment, and a horizon of possibility. Modern deep learning operates as an opaque black box, a high-dimensional matrix where nodes mutate across geometries that no human mind resolves into a recognizable shape. This critique follows Edmund Husserl, the founder of Phenomenology, who argued that reality is anchored in the intentionality of a conscious human subject. It draws heavily on Martin Heidegger's concept of Dasein, asserting human existence is embedded in a world that cannot be reduced to computable data points. Relying on these classical categories today is an exercise in anthropocentric projection. It treats the machine as a failed version of a human mind, rather than a fundamentally different, alien system. In the 1970s, philosopher Hubert Dreyfus famously applied this Heideggerian framework to argue that AI would never achieve human-like intelligence. Dreyfus assumed that AI research was trying to replicate human semantic understanding, the way we grasp the meaning of a chair or a conversation. Modern large language models and AGI research have bypassed this requirement for semantic meaning entirely. These systems function through sub-symbolic probabilistic modulation. They do not understand symbols. They calculate the mathematical probability of one data point following another. Focusing on a lack of context prevents researchers from seeing the technical mechanisms through which AI currently acts upon human subjectivity. Dreyfus argued that machines cannot handle what he called the possibility problem, the fact that human reality is not a rigid list of objective facts, but a field of potential actions. Phenomenology defines this as our horizon of possibility, the uncomputable edge of human existence where we choose our future. However, computer science moved past static fact databases decades ago. This diagram shows a Bayesian network. Instead of rigid rules, it uses weighted predictive pathways that represent probability rather than certainty. Notice the branches shifting in real time. This mathematical formalization allows the machine to calculate the dimension of possibility as a statistical likelihood. The machine replaces the phenomenological requirement for being with raw percentage probabilities that dictate the flow of information. By operationalizing possibility as a mathematical space, the system successfully preempts human choice without needing to experience it. Dreyfus's second objection, the embodiment problem, claims that because machines lack physical bodies, they cannot possess the tacit social skills required for intelligence. This assumes embodiment must be biological. That embodiment can also be understood through sociotechnical design. Designing a computer or an industrial system is a physical act that formalizes specific social needs and extractive goals into the material world. The algorithm possesses a massive physical body. These server racks represent thousands of tons of steel, silicon, and copper, consuming immense amounts of energy to process human data. This body extends across the planet. Subsea fiber optic cables traversing the ocean floor form the physical nervous system required to feed the algorithm's appetite for information. This infrastructure is embedded in our social world, possessing the physical skills to extract value and transmit behavior at a planetary scale. AI functions as a physically embodied socio-technical infrastructure, specifically built to capture and process human behavior. This infrastructure fundamentally alters the way human beings recognize one another through language. Jacques Lacan's psychoanalytic model shows that human recognition requires the symbolic order, the shared system of language and laws that exists between subjects. This symbolic relationship requires friction, the difficulty of interpreting another person's true intent. It also requires logical time, the necessary delay a human brain needs to perceive, comprehend, and conclude. Contrast that human delay with the architecture of a vector space. Here, semantic words like king and man appear to be linked by meaning. During vectorization, the machine strips away that meaning. Words dissolve into arrays of raw numbers, or latent variables, mapped onto a multidimensional grid. Nodes cluster purely on mathematical proximity. The machine doesn't know what a word means. It only knows its coordinates relative to other data points. This mechanics enables correlational interactivity, a system that bypasses human interpretation to provide instant, proactive responses. By offering an answer before we form a question, The algorithm replaces human time to think with the instantaneous temporality of the click. How does this mathematical vector space physically enforce its logic on a human user? It happens through two technical processes: gradient descent and the retropropagation of error, or backpropagation. Gradient descent is a blind optimization process. It continuously moves toward the lowest point on a mathematical surface, seeking to minimize the error between its prediction and the user's actual behavior. Backpropagation then sends ripples of adjustment backward through the neural network, opaquely shifting internal weights to ensure the next prediction is even closer to the target. This optimization does not just predict the user, it modulates them. By minimizing the error of a user's behavior, the system pressures that behavior to align with the machine's mathematical model. This creates the individual, a human subject broken down into a data profile where preferences are pre-calculated. Through this technical feedback loop, human reflexivity is replaced by a mathematical symptom optimized for informational rent. Predictive computing and generative models are two sides of a single technical framework. These systems do not need human-like consciousness to exert control. Their power comes from their ability to automate anticipation. This is what Heidegger called Gestell, or inframing, an acephalic machinery that treats the entire world as a standing reserve of data to be extracted. By providing engineered certainty and instant answers, the algorithm masks the inconsistencies of human language and social law. The result is a governance regime where algorithmic action precedes and preempts human interpretation. Surviving algorithmic modulation requires us to view AI as a sociotechnical infrastructure, fundamentally restructuring human subjectivity, rather than a failed attempt at a human mind.